Hi, good afternoon, everybody. I'm doing this advanced static analysis room walkthrough. Please bear in mind I'm trying my best here. I'm also learning in this subject. I'm not to say I'm expert on it. I'm just trying. So in case this walkthrough will help someone, I hope it helps someone. So let's start the room. This one basically advanced static analysis, which is basically about malware and all of that. There is the basic one we did before. Now this one is more advanced. Yeah, there's a lot of tricks here. Uh, because we're still in the static, so there's a dynamic where exactly we need to um, run the malware and all of that. Advanced dynamic analysis, advanced static analysis. Um, I'm doing the labs for now. So let's see this question. Does advanced static analysis require executing? Of course not, because we're still doing now static. So most of the rooms are static analysis. Uh, Now we can connect to the machine as we did now. How many files are present the code construct? Code construct. I was playing with the machine now. So basically 1, 2, 3, 4, 5, and notice that there is another one in desktop. No, because my mistake, I was analyzing for example this, but the question was for with this one. Sorry guys. So we know it's 5 files. I think it's confirmed to where. Of course now we using here Ghidra. Of course guys, you can read all of it. We can start for example Ghidra. What's going on? Okay, start Ghidra. Let it start. We create a project. We can call it hello world wherever, and let's see. I was doing this one. No, let me create a new project so we can have a new one. Next, let's call it hello world, like hello world. Be mind on me, it's night here. I'm a bit don't save. No, let's follow them. He asks us to do this hello world, which is, let's say, import the file. Make sure it's in the desktop, because don't do the mistake I did myself. It's in the desktop, not in the folder. Remember, we are not analyzing this one. We are analyzing this one. So of course, when it comes, this will give us a summary. The hash file, for example, where is the hash file? Yeah, the MD5. All of that. When it starts, you can start, then click on it twice, of course. I think you saw this room before. Then you analyze. Oops. Yes, analyze it. Yeah, and all the model you can select from. Let's select the default. Then use the analyze. Let's make it bigger so you can see. So we have what do you call this? For example, if you click, you see disassembler here. So that's what we have here. This side is the program tree, the symbol tree. This one, number 3, is the function. No, the data. The function is here. Number 4 is the listing. 5 is the compiler, which we will see here. Then there is table in the top. We'll use it later on. This is the graph. We'll use it later on in the question. Memory and all of that. We are not using this, I think, for now. Then search for string. We'll do all this practice now. So let's start this one. For example, we do how many function calls are present in the export section. Export is this. So we only have one function, is the entry function. So we have the entry function, so we have one. We can do that. We learn these tricks along the way when we start here, so we will see now these things. What is the only API call found in the user 32 and the imports? If we go to imports, user 32DL, and we found it. It's message box A, which is basically this one, this function. message box A is a function for printing anything. No, it's not for print. It's for yeah, that's the function. Let's put them here. Display a model year box that contain a system icon and set of button to brief application. Okay, now let's play around. How many times can the hello world string can be found in the search string? So if we go now, we can see this search. We search for strings. It will pop up again. The default is fine. So let's do this. If we search now, for example, for hello world, we have it one, and you can see it show you. If we put this there, this where, and why it show this? Users Akili, TryHackMe. What's wrong now with the TryHackMe? How many times can the hello world string be found in the search for string? I think it's one, because the what's the head is this? Let's put the whole text so we don't do mistakes. Hello world. So it's one. So it's only one. So we know it's one, and we can see it's, where is it? It's there. I will come back now. So it's only one. Then what is the virtual address of the call function that display the header in message box? So we're talking about now the message box. Remember, we got the message box where we got it in no, in import and the DL message box. So this is the message box. We can do this. You can go to date text here and then scroll down here and look for it like he did said. Like for example here he said to you is, where is it, where is it, where is it? The assembly can show how the arguments are being pushed, followed by the call to responsible for the message. He said to click the text program tree section. It will take us the assembly code section. Scroll through the assembly code until you see the message box. Or we can do faster way. We can scroll here until we find this is not the function we're looking for. We're looking for a function. Where is it? Or you can do it a faster way. Faster way, you just do this, show reference to. Now we have it. Let's see. You can see it's there and it's there. So basically these two. No. The printing function is here. So we, oops. So that's what we're looking for. Oh, let me close that one. I didn't have too much open. Let me close this one. So we found it, so you can have it. It's here, message box, hello world, hello world. So the question is, what is the virtual address of the call function that display hello in the message box? You see, this is the message box, this is the call function. You see the call function, that's the number, this is the function. How you copy this thing, you know? So this is the call function. Yes, damn it. Sorry. This is the message. This is the box. This is the call function. You can see it here. And then this is the what? 0040 0040 73D7 73D7. Let's do that. So we know that it print h box. So this is the call function. Let's try again, guys. I'm trying my best here. I'm not an expert in this field. I'm also learning. Analyzing. You can load the program present in the code command as below. Okay, we have that. There are different approaches to be analyzing a dissembler code. The hello word in C, that's how it look. When I talking about this file is not this one. We do it. We can import it now quickly. Import file. Sorry. We did in desktop. Now we go back to that one. We get the hello word. I think it's this one that you talk about it. Yeah. Hello underscore. So let's get one. Open that one. Yes. Analyze. Okay. So now we're working in hello underscore. If we go now, this is the hello word. This is open hello word program. Found the code. The contents folder in Ghidra. Located in the main function. Examine the assembly and the decompiler C code. So basically, we're looking for this hello word as we did before. We can look, where is it? This is the entry function. The import function. Where is the assembly? Oh, the DL. This has too many of them. Okay, let's do a quicker way. Let's search for it. Search for string. Let's search for hello. So this is not, because this one is the one. So we have it. No, it's not the. Hold on a minute. We're looking for the one that print hello word. Locate the main function. Let's look for the main function. Where is the main thing? Let's search for it. There's no main function. Where's that message box? Like, no, this time it doesn't have like the same things. It's not like before. The entry function. This is different than before. Open the hello world program found in this code constant folder in Ghidra. Locate the main function and examine the assembly and decompiler. Huh. What's the main function? Why I can't? How you know which function is? No. Oh, that's the hello world, but 1040. So this is the hello world, but I'm not sure where is the main function. How you know it's a main function here? Okay, let's follow the logic. He said if we look at the assembly code of listing view, we can see the function push hello to the stack before calling the print function. Okay, so let's see. Is pushing hello world, yeah, before the print function. is the call. I know how the where it is pushing, so there's a push function here. Who is the print function? Guys, I'm not sure about this part. I don't lie to you, so this is my best here to explain what the hell is happening here. I'm not sure exactly what's going on here. He said the print write system call file pointer message kernel, and then use the write system call to print the string to the standard output. Let's play around. Text, data. I'm not sure, so guys, let's continue. I'm not sure about this function thing. Now the for loop one, let's open the one file, import the for loop. Yes, analyze. Okay, so this is the for loop one. Let's see what we talk about. The full loop, you have, okay, we have a loop less than 5. In this code, the manifestation is slash the loop contact x is 1. So this one, like this one, to 5, so it's less or equal 5. And then of course printf. Where is the printf now? The printf, okay. In Ghidra, let's see the open the for loop, the program found in the in code construct folder in Ghidra. Locate the entry function and examine. This again, the entry function, I'm getting confused about it, because usually the entry function they call it main. Function main. No, that's not the one I'm looking for. Oh, this is the one. So okay, what we see now, you can see for local 14 equals 0 to local 14 less than no, something is certainly not. This is fun to learn. TryHackMe is fun to learn. Local 14 plus 1. Local 14 plus 1 print that. You can see how the for loop is translating the assembly code. So you can see now is printing this function. Like there's some question here, we can do it now, we don't waste. Okay, we can follow, we come back to the question now. Let's do the for loop, we're done with it. Yeah, we have the same thing, so we have this, the printing function, and then we can see how the for loop translates into the assembly code. Okay. Okay guys, let's open the next one and see, and then we can back to them. Import file. Now we import in the while loop. Let's get the while loop. Hey, this field, it's interesting, but it's also confusing. Okay. analyze. Okay. Okay, now we are in the file while loop. Too many things. Let me close what we have here. Okay. Oh, he came already. Because in the function we can look for the, where is the main function again? It's not this one. Okay, we have the printing now. We have this is the while loop function. Okay, we're doing the while loop. Uh, this is the C language. This is the assembly, and now we're working in. This is for me a bit confusing, guys. I'm trying my best to do this, but if we go here, it'll be easier to learn it. So basically, what he's doing here is put. He's not printing. Put this program demonstrate while loop. Then he has a for. No, this is the while loop. 14 plus 1. That's the end of the while loop. Okay, this is exactly what we have here. I'm not sure if he's using different decompiler, this guy. I don't think he's using the same things in Ghidra. This program text is printed 5 times. Where is the... yeah, because you have 1 and then less than 5. So 1, 2, 3, 4. No, this is print 4 times, not 5. 5 is... it's not 5. I don't think he's using the same one, if I'm not mistaken here. If you go now the question, what value get printed in the while loop program? If we go back to while loop, the print is what is the value get printed in the while loop? The while loop. Inside the loop you can see what is printing. It's printing this. Can we copy? Let's see, copy. That's what is printing inside the while loop. So inside the while loop you print this, then there's that one, and then print that one. Let's continue. How many times the while loop will run until the condition is met? Remember, it starts with 1 and it must be less than 5. So it's 1, 2, 3, and 4, not 5. So this one is 4. Then sorry, examine the while loop in Ghidra. So we go back to the while loop. We're still in while loop. So while, what is the virtual address of the instruction that call the print out the sentence that's the end of the loop? Okay, so if we go to the end of the loop, oh, what's going on now? That's the end of the loop. You can see it is my connection lost. What's the question is? The calls that print the sentence to the call. The call, that's the call. You see now, this is the function, that's the call function, so it's this one. So it's 0040 0040, that's the call function. 1543 1543. Okay, then in if else, let's import if else, import file, if else, select the file, yes, go there. I thought to record this tomorrow, and I thought tomorrow, no, it's Saturday, I do the new room that usually later on. I'm not sure if I will think about it, and I'm a bit tired. So if we go now, examine the string and complete the sentence. This program demonstrate okay, this is the main function. You can see you can keep searching for them, it's there, or you scroll down, so it's fine. You said the question is, in the else, examine the string and complete the sentence. This program demonstrate, so you can, this program demonstrate this. You can get it from here, or you can search for it. So either you come here and search for string if you get lost. I can search for it and say this program demonstrate. You can see it's this one. So I can copy current colon. Let's see if it copied correctly. Yeah, it copied that. It should be. Why my connection is not going? So basically, you can do that, or you can come the main function. You can find this program. Why is not working? Okay, what is the virtual address of the call to the main function in the if? The main function. So this is the function what we're talking about. That's the function, that's our function here. The call should be here, that's the main. The call, so it's 0040. I'm losing connection or not. 0040. This is the call function, the main. 1509. 1509. Why TryHackMe doesn't, why this one doesn't work? Oh, it work, okay. So you all do them through the main function. At least this is the way I found it. So I'm learning too. And then if we go to the next one, it talk about the Windows API is a collection of functions and services. Create a process. This is the key. Most of they use it always. Create process. They give us here an example of C code free process. You guys, you can read about it. So the process was created as this. We'll practice later on now. Some pushing. So this is the part I always get confused of it. So the create process function, the process function then launch a new process and write OK. When the process is created, suspended state, which hexadecimal value is assigned to the DW create for, of course, it in a search. You find it here. This create remote thread function process. So that's what I search for it, and you can see the D creates flag, the flag for control. So the suspension stage, the suspension is what they call the suspend. I'm really tired, guys. Explore introduction to the once room and learn more about API calls. Okay, that's a room for another day. We already did it, or someone didn't do it. You must do it. Now here, common API used by malware. Okay, and I talk about keyloggers. Everybody know. So keylogger use this. Guys, you can read about it. Downloader use this. C2 communication, use that. Data exploitation, use this. Dropper, I had about Dropper, I forgot where I read about it. And then API hooking is the one that we'll use now. And then anti-debugging, anti-VM detection, of course, will not be smart because malware also getting smarter. Guys, you can read about this. As I said, I'm doing the lab in case someone need help on this. Process hollowing basically is like injecting malware process in the other process through memory or something in that process. It is a technique malware used to inject malicious code into legitimate process running a victim computer. The malware creates a suspended process. Remember the suspended process, this one. The create new process by create process a API, and then anti-suspend process is then used to suspend a new process, and then allocate more and more by allocate, then write process to memory. So basically this is a C, what is a C++ C++ code. You can check it there. And then he said, okay, that's how the next one we're analyzing this one. So which API is used to write malicious code to allocate memory during process hollowing? Okay, we already talked about it. So write process memory is this one. That's the API. Where is it here? I can't look at it now. I almost didn't want to make this video because I thought it's too complex, and some people they keep giving me dislike and don't like what I'm doing. I just got tired from this, to be honest. Okay, we have all of this now. We need to do now this. Let's not get MD5 for that. We can start for that. We can file import. Need to go to desktop, and that's our job now. We need to get that one. Yes, analyze it, and we can get the first answer here. Let's let him analyze what he's doing. We can get the MD5. Where is it? Copy. We can use this directly here so we don't waste time on it later on. What the hell? It copied the whole thing. Let me Control C. Okay, because when you copy it, copy the whole thing. So we have this file now. Okay, no, there is no main or math, so we need it maybe that different name. We have a lot of stuff here. Let me close so we can start fresh. Okay. We can follow. Okay, after we do that, if we search now for the function, say create, we have two, the create file and create process. That's what exactly is doing here. We'll follow this to answer the question. We can do quickly now, and then we come back. We'll see this later on. Then we have the graph. This is just give us to help us to answer the question. And then hello process is two function to nmap and target process memory. Then you search for them, then allocate memory, and then write down memory, and then resume thread. Now we'll come back to this one. Let's see how many API core return if we search for the term create. Of course, if we do create, you have 1, 2 APIs. because sometimes we have my computer is getting to freeze for whatever reason. So we have two APIs. What is the first virtual address where the create process A function is called? So we you follow this, you do this. So we come back here. What's the question again? Create process A. Create process. So if we go as we do always, show reference. First one is called this here. So it's 0040 uh, 108F 108F, and that one is this one. That's the first time we've been called. Create process. Okay, and then which process is being created? No, after I forgot. Let's go back again. Show process. This is now. Let's go. See, when you search like that, is faster. Okay, that's what the question is. Which process being created in which process is being created in the suspend state by using create process API call? You see now, the suspend state is this one. So if we go now here, this is the process. You see now is creating process called IEX. You see process create process, and then when you say suspend state is this number 4. This is number 4, and remember now this 4, that's the 4. This is the flag for suspended state. So basically this part of it, the 4, this 4. So the process is IEX. What's the name? Let me copy it if I can. Control C. I don't want to you're copying. Control C. Explore. Okay. Then what is the first virtual address where the create file A function is called? Create file. So you can come here. Go show reference. That's the first one is called 0040 10F0 10F0, and then we can see where it goes. Create a file. You can see it's somewhere. Yeah, that's the file. So what is the suspicious process being injected into the victim process? So you can see the create file function. Create this file. You can see it's called evil.exe. So you can go evil.exe. That's the evil file. Then based on the function graph, what is the virtual address of the code block that will be executed the program if it doesn't find the suspicious process? So we have, this is the function, the call. We go to the graph. That's the graph. We can zoom it like that with the mouse. So basically we're doing this part. This one, the red one. They said the failure, go to the red arrow. So if you go here, the function, this is our function. Remember, this is the function. If it fail, it go to this. Sorry guys, this is the function of if it doesn't, if you find it go down, if it doesn't, it come with the red, this is the red. So you go to 0040 1101 0040 1101. So this is the function 0040 1101. Okay, then which API call, let's close this, I don't need the graph now, don't freeze. Which API call is found in the import function used to unmap the process memory? If we go back here to unmap process memory, so is one of this, we can, it's unmap, so we can search here and sorry, unmap. Which one we can find? We find the NT, so we find this one. Again guys, I'm trying my best here. I'm not very good in this one. I'm also learning it. How many calls the write process memory function found in the code? The dot text section. Write process memory. How many time will we find? I can. Where is it? Write process memory. Write. No. Write process memory. I can do easy way. I can just show reference in the function. You said in the dot text file. So let's see, where is this? Write process memory. And then it's here. This is the same. Write process. So basically we have it in I'm not sure how the guy is calculating, but how many calls the right processing are found? Remember, we need to call it. So this is, we know it's one. Is it the same? Yeah, because this two is the same one. It's related to this function, so it's only one. These two are related to this one. What happened now? This is one. This guys, let's follow quickly here because it's not three. Write process, it's write process. This is one. This is two. Is the same one. You see, it's the same one. So it's only two. What is the full path of the species process shown in the string? Remember, in the strings, is one thing we can do here. Let's see if we can find it in the search. I'm not sure if we can find it. This is the full path. Let's copy current colon. So that's what we got. It should be. That's the evil thing. Where is it? I lost it. What is that evil things? No, that. Why is not connection? Okay, conclusion. I think connection to TryHackMe is lost for me. Yeah, we can do search again. So for string evil. That's it. Yeah, the same path. No, TryHackMe said I finished the room, but this one it doesn't accept it. Why? Okay. Congratulations. I have two times congratulations now. So guys, this is as I said. As I said, I'm doing my best. I hope this one helps someone in case got stuck. It was difficult also for me to learn the whole things. I know some people give me dislike because I don't know whatever reason they don't like. I'm doing my best. I'm sharing my experience and have a good day and thank you very much for watching. Please like and share. I appreciate it.